start practicing engineering equation solver. So after this class, I'll give you software details which you can download and install by yourself. Okay, and then you can practice. In this class, whatever this 7 or 8 problems we have solved in our last tutorial, let us solve through EES. Okay, because that would be convenient for you, and then you can verify how the conventional method we are following, how are we following for this particular EES. Okay, so I think this presentation you have with you, which presentation? Previous class tutorials presentation. I hope I have uploaded in that. Yeah, okay, this presentation already there. Tutorial and properties, its name itself. Even the same day, 4 days ago, I have uploaded this. Okay, so please open that. Then, so this is your presentation. I'm keeping it aside. Yeah. This is engineering equation solver platform. Do you able to see this both? Can anyone please confirm?
Yes, sir.
Yes, sir.
Okay, okay, nice. So problem number 2, as you know, okay, so this is the problem that day we have practiced. This is your ES platform. If you go over here at the down, once you open, there is units here. Yes. If you click on that, double click, just double click. Okay. So this kind of window would be open. Okay. There you can click whatever. Okay. We are following SI system. So SI here and mass. Okay. And Celsius we are taking, but not Kelvin. But still you can take Kelvin also, no problem. Okay. Whatever. Even you can take in terms of bar, or otherwise you can take in terms of kilopascal for case of pressure. Okay, that is up to you. Okay. But since it is the SI, these all are SI system. Only thing is whether you are taking in case of Pascal, this will be very big unit. Okay, big unit in the sense magnitude will be very high. This is bar. Okay, and this is kilopascal. This is a megapascal. Okay, these all are mutual conversion to each other. Otherwise, nothing. And energy also. Energy means all together. Internal energy, enthalpy, okay, these all the things are coming over here, whether in the joules or otherwise kilojoules. Okay, so this you have to initially you have to set, but default it is setting like that. But before after installing, before starting your problem, please check it once. Then after this, whatever the present software is there, EES. Okay, is a very simple software. Okay, even easy than ever this thing, whatever, MATLAB. Okay, the advantage of EES is all the property tables are interlinked. Okay, that means data is given over there in the behind in the executive files. Okay, so whatever, only thing is how to use certain syntax, otherwise nothing. Okay, so suppose see over here, this is our problem. Okay, so what was the problem? Get pressure P1 equal to 5 bar. Okay, this is the point. Okay. There, the mass fraction was 0.5, and then this point has been reached to at this level. Okay. Okay, what is this point? At this point in the problem itself, it has been given x2 equal to 1. That means what? This is saturated vapor. Okay, saturated vapor. So what you need to find out? Final mass. Okay, final mass and final pressure. Okay. This is such a simple problem. Okay. So here we are giving P1. That means pressure 1. Okay. This is 5 bar. 5 bar, but what is our units? Kilopascals we have given. That is the reason I am giving 500 here. Okay. Then after, what is the X representing? Dryness fraction? Yes, dryness fraction at 1 means this one is representing process. Okay, this 1 is representing your process, means 0.1. Okay, and this is 0.5. Okay, then here you can find out at the 0.1, you can find out your specific volume. Yes, so once you find out specific volume over here, this point you have same specific volume. Is it? Specific volume at V1 equal to specific volume at V2. Yes, this is the problem we have solved. Okay, specific volume V1 equal to specific volume V2. Then from that, okay, we have calculated this mass. Then obviously this pressure, how do you have find out this pressure when we have solved the problem? So we have taken the data table. Okay, at the data table, at this particular whatever specific volume. Okay, that is also assuming that saturated steam. Okay, and then what is the respective pressure? Okay, if it is coming in case of interpolation, okay, then we have calculated it as the interpolation. Okay. Now, what we need to do over here, we need to calculate mass as well as we need to calculate the saturation pressure over there at P2. Before that, what is the condition we are using? V1 equal to V2. Okay. Here, let us try. Specific volume is SP vol. Okay, VOL. Okay, of 1 equal to volume. Okay. What is this? This is the steam. That's what we have written. Steam over there. Okay. And then P equal to P1. Okay. Two independent properties we have to mention over here, right? P equal to P1, X equal to 0.5. Yes. We have given these properties. Let us see. Let us see what will happen. After that, you need to click this particular thing. Okay. This is giving you solve. Okay. This is giving you solve. So what we have obtained? We have obtained simply, this is the table it is giving. All the properties including. Yes. 0.188. Is the same matching over here? Yes. 0.188. Earlier what we have done? We have taken a specific volume of the saturated liquid from the table at that particular pressure. Okay. And then we have taken from the data table a specific volume of the steam at that particular pressure. Since we know dryness fraction, okay, this dryness fraction we have used, then we have calculated like this. Okay. That way, here we can directly get. However, we can calculate even other factors also. Suppose see, if you need this value or otherwise if you need this value, how to get that? Okay, this is just practice. Here we no need of these two things. Okay, but however in other problems you may be needing these all things. That's what I'm giving over here. Okay, so otherwise you can simply say VL. Volume, I'm taking it. This is 0, means saturated liquid. Okay, this thing we have obtained. Yeah, is this matching with this? Yes, exactly matching. That means at X equal to 0 means what? At this pressure, this is saturated liquid. Is it? The same thing, let us repeat over here. This is, let us see, gas. Okay, and here it is 1. Yes, then run it. See, 0.3748. Okay, 0.3748. correct. Okay. So this is at that particular point. Okay, and this is the saturated liquid. This is the saturated vapor. Now what are we assuming? This is the means whatever the specific volume at 1 equal to specific volume at 2. Okay, because this is, yes. Now we are assigning volume 1. Okay, and then pressure, sorry, P2 pressure. Okay, okay, and then V equal to specific volume 2, x equal to 1. Okay, so what is the pressure we are getting here? Okay, this is at 2, this point. What is the code we have given? At this particular specific volume, and this is the dryness fraction. Okay, dryness fraction 1 means just saturated. Okay, this is the specific volume. So what is the pressure? We have asked this to calculate. It is written you the value. This is 1036 kilopascal. That means 10.36 bar. That is obviously your answer also, which you have calculated in conventional method. However, there actually you have taken approximate interpolation. Okay, that is the reason that was not so accurate, but this is the accurate which we have calculated through your formulation as well as in the program. Okay. So how simple it is? Very simple, right? But only thing, these are all the things you have to understand. These all are matter of syntax only, otherwise nothing. Okay. But however, when you follow the conventional method like this, okay, that will be giving you great understanding about the subject. Okay, because in case of GATE exam, or if tomorrow if you are going to attend IES exam, okay, so there you will not be getting these engineering equations solver and all. There actually data table will be given to you, stream table or otherwise whatever the data table. By using the data table, you have to solve these all things. Okay, so that is another issue. Once you practice this kind of thing, suppose this formula, okay, without using this formula, here you have obtained this value. Yes, without using this formula. But these all the formulas are giving you so very depth knowledge about your particular subject. That's what whatever the problems we will be solving in conventional method. The same problems in the next class, let us solve in case of engineering equation solver also. Okay, this is okay. So and what you need to calculate? You need to calculate mass. Okay, how are you calculating mass? Volume is given. Yes, this is the tank volume. Yes, this is the in the problem itself. This is the tank volume of 1 meter cube. Okay, so at the stage 2 means at the state or so not this problem. This problem. Sorry, at state 1. Okay, it was 0.5 dryness fraction, means certain amount of liquid was there, certain amount of steam was there. Yet here, point 2 or state 2, it is completely saturated vapor, which is completely covered in the vessel. Okay. So then simply this is volume by its specific volume, whatever we have calculated just now, then you will be getting this. Okay. Here that is simply just a formula, otherwise nothing. Okay. M equal to, okay, what is the volume over there? 0.2, that is given in the problem, divided by, okay, and then specific volume 2. Now run it again. Okay. Now what I want to show you, these, so far it was giving you in a table like this. Okay. This is actually property table, we can call it as. Whatever the property related things are there, okay, state properties or state parameters, everything coming over here, okay, and whatever the numerical values in terms of the results like mass, okay, these all are coming over here in the data, okay, data window like this, okay. However, here it is showing you some small error. Why? Because you can click over here, that you can see, okay, the specific volume it is showing you. No, means we don't have anything over here. Yes, sir. So this unit we have to feed. Where can we feed? Come over here, click on this, okay, upon this, right click, okay, once you can see here, in this table, okay, here, upon the 4, click over here, this window obviously opening, then you can type like meter cube, then say simply okay. Okay, so here 3 potential unit problems were detected, right? If you run now, this will be reaching to 2 also. Okay, 2. And what is pending? This is also. Okay, here also you can enter your value. This is also. And what are remaining? One potential. What was that? That was mass. So anyhow, okay, this is the mass. We no need to worry about that. Okay. This is about problem number 1. Is it clear? So whatever the problem number 1 we have solved in conventional method, simply we just have written 4 lines of code. This is not even code also. We should not call it as the code. Okay. This is software. We are just using predefined syntax, whatever is there. Through that we are calculating. Okay. But whatever, see here you are giving right Steam. Then this particular software is going back to the Steam tables which are in background data. Okay. So in some problems we will be putting over here propane. Okay. Then that will be taking you the software to the propane. Okay. Is it clear? Can I move to next problem?
Yes, sir.
Okay, fine. Fine. Thank you. Okay. So now problem number 3. So what was the problem number 3? So this is the problem number 3. Yeah. What was it? This is that state 1. Okay. State 1 is like superheated steam. Okay. 7 bar and 500 degrees centigrade. Okay. This is superheated steam. Then in between there is one point. That point we called it as A. Okay. Here, according to the problem. There it was saturated steam. Okay. Then this is the point 2. There it was actually condenser pressure. Let us assume in case of steam expansion in the thermal power plant. This is 0.5 bar. Okay. Here at point 2, you may need to calculate many things. What is the volume in meter cube occupied by the saturated liquid at the final state? Okay. That means this is dryness fraction of something. First, you need to calculate dryness fraction. From the dryness fraction, what is the amount of liquid? What is the amount of steam we have to calculate? What we have done over there? X2 we have calculated like this. Okay. Okay. So X1 data is given. For regarding X2, only pressure is given. Okay. Then we have to calculate respect to temperature. Okay. Then there accordingly, what we are assuming, this specific volume equal to specific volume at A, the same specific volume at 2. Okay. So as we have followed over here, we have to equalize all specific volumes. Okay. Then we will be calculating whatever the mixture properties at point number 2. Okay. Even this is the method we have. Okay. In our previous class, we have solved. Very simple thing. Let us solve by using ES. Okay. In your final exam of thermodynamics, okay, the question might be coming like you may need to solve through the ES because this is the paper. I hope so, but I'm not sure. Paper would be coming from the central team. Okay, that means some other professor of our core team will be giving you. Okay, So that's what we have to be well prepared for everything. Okay. Let us see the problem number 3. Volume is given, wall equal to 1 meter cube. Okay. Yes. Then the P1 equal to 7 bar. That's what I am giving, 700 Pascal. Okay. Then P1 equal to 500 degrees centigrade. Yes, that's what I have given, 500 degrees centigrade. At this point, we need to calculate our specific volume. Okay. Then it is specific volume at 1 equal to volume. Okay. This is the fluid is steam. That's what steam. Then P equal to P1. Okay. You need to give 2 independent properties. Okay. Then other properties you can calculate. You should have 2 independent properties actually. Okay. So somehow then T equal to, then let us run at this stage. Okay. So what we got, the specific volume is 0.507 where at that location. Okay. 0.507. So even this is from the table, this is look 0.507. Okay. At that point. Now we need to calculate specific volume at 2. That is also same. Specific volume 2 means here let us consider this is 2, this is 3 for our convenience. Okay. You don't need to worry about A, B and all. Let us consider 1, 2, 3. Okay. Specific, obviously specific volume 2 equal to specific volume 1. Is it? Because even specific volume 3 also. Yes. Okay. That is 2 we are considering. Okay. And then x2. Which point is this? In between point here. Okay. In between point here. Okay. So at this point, you can calculate saturation temperature and even saturation pressure also for these two. Okay. Let us see. P2 equal to pressure, steam. Okay. And then V equal to SP, SP1, comma, at x equal to 1. Yes. Okay. And the same thing, let us see the temperature also. Okay. T2 instead of pressure, this is temperature. Okay. Then run. Okay. So this is the property table we are getting. Okay. So at 2.2, this is pressure 3.62 bar. Okay. The specific volume is same. And there actually temperature at this location. Temperature was 140. Okay. 140 degrees centigrade. Okay. That is about 0.2. Then let us see at 0.3. Okay. At 0.3. Even now, same specific volume. Is it? Same specific volume we are taking. Yeah. So now we have pressure data here. E3 equal to 0.5 bar means 50 Pascal. Okay. That we have to given. Now Now we need to calculate the dryness fraction over here. Yes, quality of the steel, that we can call it as quality of the steel. That is X3 equal to quality. Okay, you have to write quality if you want to get what is the dryness fraction. This is the syntax: quality, pressure, temperature, simple, quality, nothing more. Even it is volume. Okay, our working substance is steam. Okay, then where you are calculating it, P equal to P3. Yes, then what you are doing, V equal to specific volume V3. Yes, this is the run. Okay, and then what you got? Yeah, this is the third point. Specific volume we are considering it as same. Yes, 50 Pascal. Dryness fraction is 0.1562. Okay, dryness fraction is how much? 0.1562. Okay, so is that same what we have solved? Yeah, this is approximate. Okay, it is like that. Okay, then how much this much of percentage is, means like 15.62 percentage is steam, the rest of that is liquid. That is the reason what we have done over here, 1 minus this value, this is the liquid. Okay, this amount means fraction, this fraction is liquid. Then rest of these all are simple calculations. Okay, like normal calculations you can multiply with whatever this liquid volume you can find out. Okay, and then these all things you can multiply and you can get rest of this data once you type it. This is about your problem number 3. Okay, so is it clear? Can we go back? Can we solve problem number 4? What is the problem number 4? Yeah, this is giving you point variables. This is nothing. In the problem number 4, 2 parameters, means 2 independent properties are given. Okay, once you type 2 independent properties, you will be getting certain data. Okay, so for problem number 4, this is A, B, C are there, right? I'll show you A and B. Okay, so and then C you can calculate. Okay, is it okay? Problem number 3 is fine. Shall we move to problem number 4? Because problem number 5 and problem number 6 are very interesting. Okay, so for that, once we complete this problem number 4, then we can solve them within our time. Okay, then. Do you have any doubt in this? Okay. Okay. So now regarding problem number 4, the working fluid is a refrigerant. Okay, 134. Yes, refrigerant 134. So here this is 60 degrees centigrade and its specific volume is 0.072. Okay, then what we are finding out? So what is the state of this? Okay, what is the state of this? What is the pressure over there, and whether it is superheated or saturated, whether it is liquid, what is that? We are finding out. Okay, let us see. First, let us enter the given data. U1 equal to 60 degrees. Okay, and then SPO1 equal to 0.072. Okay, and then at this location we are calculating. Okay, so specific volume again. Okay, so if the specific volume whatever you are calculating, okay, a dryness fraction 1 suppose. Okay, so this value is more than that, that means what? It is superheated. If this value is less than that, then what does it mean? it is saturation, means in between latent heat stage, certain dryness fraction. Okay, so let us see over here. So here V1 equal to volume, okay, R 134 A. So the liquid, the fluid is refrigerant 134 A. So you have to write like this way, R 134 A. If somewhere refrigerant 22, if you are there in our problem also, there you need to write R22. Okay, then comma equal to D1. Okay, then X equal to 1 we are taking. Okay, let us calculate what it is saying. See here, this whatever the volume, yet X equal to 1 means saturated. Okay, saturated gas of this particular working fluid is 0.01143. Okay, 0.011. So, but what is our given volume? Given value volume is even 5 times more than this particular volume at saturated. That means what it is representing? Obviously, this is superheated condition. Okay, this is superheated vapor of refrigerant 134A. Okay, then we need to find out pressure over here. Then pressure of 134A equal to, otherwise here you can use one word simply Psat when you are calculating saturation pressure. P underscore sat. Okay. In that case, let us see. What is the pressure? 16.83 to 3.63, right? Okay. Okay. This is superheated, right? We should not calculate it this T. We have to calculate it this volume V1. Okay. V1. Let us check. The saturation product actual only temperature as the parameter. Okay. So first let us calculate temperature for this. Let it be P. Let us consider for this. This is 2. Okay. Temperature 34 A. Okay. Equal to or otherwise directly pressure also we could calculate over here. Is it? Let us see. Let us see. Let us see. Okay. This is giving it 660. PG. We are considering even here also we have P2. What is the volume? So let me check even data table. Okay, here we need two independent properties, but we are suffering from that. Okay, so we have to depend upon the table only, I think so over here. Otherwise, it would be difficult. Yes. Okay. Okay. So I'll see about the problem number 4. Okay, and then I'll let you know, because here we have only one property over here. Okay, that is representing superheated state, but saturation we have to calculate. Okay, to calculate the saturation pressure. Okay, and even we need that one particular point over here. Okay, that we don't have. Okay, so let us go to problem number 5. Okay, I'll try to solve this and then I'll send you the answer also. Problem number 5. What problem number 5 is saying? Yeah. So it was over here. Okay. This is saturated water. Okay, saturated water. This saturated water cool down or otherwise reduce the pressure to the certain lower pressure. There actually, since it is the pressure reduced, certain mass fraction means like here certain mass is evaporating. Okay, it is finding out certain dryness fraction over here. Okay, that we have to calculate. Very simple problem that we have seen over here. Okay, and even we have to calculate here Q also. To calculate your Q, you need to have idea about your internal energies also, right? So that let us see. Okay, this is problem number 5. Then what is given over here? T2 is 50, that is given. Yes, and then there, this is point number 2, right? Here you can calculate saturation pressure, okay, for this particular thing. P2 equal to, if you know the temperature, okay, at the saturation condition, okay, if you know the temperature, for that you can calculate saturation pressure by using this particular syntax, like P sat, okay, this is steam, that's what property means, fluid is the steam, okay, then T equal to T2, okay, then let us see. At every case you can run it. How much we are getting? 12.35 kilopascal, is it? So let me check when we have calculated, did we get it or not? I think we have not calculated the pressure over here because it was not required, maybe. Okay, okay, no problem. However, for us we need, okay, in the problem we need. Then what is at 2, what is the dryness fraction? It is already given over here. This amount of mass is saturated vapor, and rest of the mass is, this is actually 2000 kgs total mass. This is total mass of 2000 kgs. In the 2000 kgs, at the point 2, it was 0.03 kg of steam, and rest of that is still water. Okay, that's what we can consider x2 equal to 0.03 divided by 2000. Is it? That is giving you your dryness fraction over there. Okay, your dryness fraction. Then what we need to calculate? We need to calculate here Vg and even Vf. Okay, Vg and Vf. This is the procedure, right? We have followed. Okay, then you need to calculate internal energies here. Okay, you need to calculate internal energy U1, U2. Then only you will be able to find out Q. Okay, yeah, that let us see. Vg volume steam equal to T2 comma x equal to 1. That means what is this? Okay, saturation stage. So Vg you are getting over here. Okay, steam, yes. Okay, so this is Vg. VL of 2 equal to the same thing. But however, this is 0. Okay. Okay. We are getting this. Then what we can calculate? The specific volume at 2. SPN wall equal to, okay, or otherwise you can directly get also, okay, but whatever our practice we are following, that let us see. Okay, that way, then what is it is giving you? Volume of 2. Specific volume of 2 equal to VL of 2 plus x2 multiplying, okay, Vg of 2 minus VL of 2. Vg of 2 minus VL of 2. Yeah, This is our conventional formula, right, which we are following. Then what it is giving you? It is giving you your dryness fraction. Okay. This is, yeah. This is obviously, okay, this value. Then what we need to do over here? You need to calculate your internal energy. Okay. What we are considering, specific volume 2 equal to specific volume 1. Okay. Specific volume 2 equal to specific volume 1. You can simply assume. Okay. Then internal energy U1. When you are calculating internal energy, you have to give this syntax like int energy. Okay. As like volume, pressure, temperature you are typing, right? For this syntax is like int energy. Okay. Then it is like again our fluid is steam. Yes. Then it equal to T2. Okay. Otherwise, here we are getting to specific volume, right? So we can V equal to specific volume we can give. That would be more better. Okay. V equal to specific volume. We are marching to x equal to 0. But however, specific volume 1 we have not derived, right? So here what are we considering? Specific volume 1 equal to this volume, this specific volume, both are same. Okay. There we are calculating our internal energy. Okay. This is the internal energy. Okay. How much is this? What is the table giving? Yeah. This table also giving 948.2. Okay. Here we are getting 946.8. But anyhow, these are interpolated or some other how. Okay. So here, whatever, this is well calculated data. Okay. So that we have calculated. Internal energy U1 we have calculated. Okay. Then U2 we have to calculate. So this is like a constant container, right? This is constant volume chamber. Here work is 0. This we have discussed earlier. Here work is 0. Only heat transfer equal to delta U. Okay. Delta U is U2 minus U1. U1 we have calculated now. U2 we are calculating like this way. Yes, sir. So then once you do this, then U2 what can we write? In energy, then again fluid steam. Okay. Then equal to T2. Okay, T2 we have already defined. Yes, sir. T equal to T2, and we are considering this is internal energy, liquid, internal energy, gas we need to calculate. Yes, sir. So because this is at location 2. Okay. So this is liquid 2 at x equal to 0. Okay. Okay, this is 209.3 liquid internal energy. Look here. This is the thing we have taken from the data book. Yes, this is the thing we have taken from the data book. Similar way, what are we doing over here? This is at x equal to 1. This would be, yeah, yes. Once you run this, then what are we getting over here? Yeah, 2443. Where is, yeah, this thing, 2443. This is the value we have obtained. Yes, fine. Yeah. So then the net U2 you can calculate from these two. Yes, net U2. How would you calculate? U2 equal to UL, right? Yeah, UL2, yeah, plus X2. X2 we have calculated, I think. So, yeah, X2, it is here, Brennan's fraction already. Okay, and then UG2 minus U. Okay, that way U2 we are calculating. Let us run. Let us see. Okay, the function X2 is not defined. Okay, here you need to put multiplication symbol. Then let us see. Yeah. Okay, and then U2 value we will be getting. Then what we need to do? These all are specific. Okay, but we have mass over here. Yes, we have mass over here. That is the reason. What shall we do? Q equal to, yes, 2000 total mass, anyhow, whatever it is, steam or gas. Okay, multiplying U2 minus U1. Okay, yep, and then run. Okay, so what is the value we are getting over here? Minus 1.475 e power 6. See here. Yeah, minus 1.47 e power means 10 power 6. Yeah, obviously our units there itself we have given at the beginning here, kilojoules. Okay, that is we are getting over here. These anyhow 6 potential unit problems are right. Click over here and whatever. Okay, these all are also volume. These are also kg per kilojoule per kg. Okay, once you enter these all the things, these will be vanishing. Okay, this is the value we have obtained. This is just practice. These all syntaxes you will be remembering. I think you are taking this video. Yes. Okay. So these are syntaxes you will be remembering. If it is enthalpy, you will be simply putting enthalpy. Okay. So let us calculate the same thing. Enthalpy. What does it give you? This is, let us see, H. Okay. And then here instead of int energy, that is internal energy, right? Then let us put okay. This also will be giving you certain data in your table. Look, this is enthalpy it is giving you. Okay. Yes. So like that. So these all are just writing like this one, otherwise nothing. These all are the very common syntaxes. Then you can get even once you click, means once you type in the Google itself. Okay. So engineering equation solver for thermodynamic problems. Okay. Then you will get these all commands. This is not at all difficult. Okay. For you, it is not at all difficult because you might have practiced data structures, C programming. Okay. So in your first year and even the second year, first semester. Okay. So like that, simple. Okay. No coding involved. In case of C and data structures, what you have done? You have written these all things, for loops, do loops. The C programming have you done in your course? C or data structures?
Yes, sir.
Can anyone, pardon?
Yes, so we have done C programming.
Yeah, yeah. There actually you will be seeing if condition, while condition, do loop, for loop, okay, and then these stacks and all these all things, okay. So compared to that, this is nothing. Yes, this is nothing. The only thing is we have to have command about these all the things. So you should remember these all the things. Okay. So even these data tables and all, you no need to go and check what is the pressure, saturation temperature. These all and all you no need to check. Okay. So this is about, we are already running late. Okay. And now I have another class, that is theory of combustion. Okay. So this is about how to solve ES. For every tutorial, let us solve conventional problems also. Let us solve through ES also. No need to worry about that. Not only this particular tutorial, every tutorial I will repeat like this. Okay. Okay then. Okay. So problem number 6, let us see in the next class. Okay. Then let us move to new topic. Okay. Okay then. Thank you. Thanks a lot.
Thank you, sir.
Thank you, sir.